Okay, so here we are looking at solving limits algebraically. And whenever we do this, we first start by simply doing a plug-in of the value x is approaching just to see what we get. And at first, when we plug it in, we see that we get 0 over 0. And this is known as an indeterminate limit. When we say it's indeterminate, that means it can go to a real number that's finite. It can go to infinity. It can have no limit at all. It can be undefined. So what we need to do now is find a way to algebraically manipulate this expression, the argument of the limit. And with this comes some pattern recognition. So we need to recognize certain patterns from algebra. And we should recognize that x minus 3, when it gets multiplied by its conjugate, the square root of x plus 3, that when we distribute this, we get x minus 9, which will match what's in the denominator and allow us to cancel that expression out of the denominator, getting rid of our 0 in the denominator. And we say, okay, well, we can't just multiply the top by the square root of x plus 3. That would change it. So we have to multiply both the top and the bottom, because that means we're multiplying it by a form of the number 1. So multiply top and bottom by the square root of x plus 3. And this is just another way to write the number 1, because x square root of x plus 3 over itself simplifies to 1. Now we get a limit that is going to be expressed a little bit differently. And we know that the top, we've already looked at how the conjugate multiplies out. The top becomes x minus 9, and the bottom becomes x minus 9 times the square root of x plus 3. And that was our goal, to be able to get this x minus 9 to cancel. Since everything cancels in the numerator, it gets replaced with a 1. So now we have the limit expressed in a new way because of algebraic manipulation. And we say that if we plug this 9 into the x now, we get 1 over the square root of 9 plus 3, which gives us 1 over 6. And that will be the limit here. That means that there is a hole in the graph at the x value we're using is 9, and the y value we get is 1/6. Here is a second type of problem where we're going to work with it algebraically. And again, always our first step is just to plug in the 5. And when we do that, we see 5 squared is 25, minus 4 times 5 is 20, minus 5. That's going to give us 1 over 0. And then we see that when we plug 5 into this factor here, we get 1 over 6 times 0. So we have 0 in the denominator. We want to see if we can rewrite this algebraically and get rid of that 0 from the denominator. So to do this, we start by factoring these expressions in the denominator. So here we get x minus 5 times x plus 1. And we've already got the factor 6 and x minus 5 over here. So now what type of pattern are we expected to look at here? And what we should see is that we're dealing with fractions of different denominators. So our goal should be to get two fractions with the same denominator so that we can combine the fractions. That's the pattern that we see, and we say, well, let's try it out. Let's see what it does for us. So what is the first fraction missing that the second fraction has? And we see that there's a 6 there, so let's multiply the top and the bottom by 6. And then we say, well, what is the second fraction missing that the first fraction has? And the second fraction is missing the x plus 1, so let's multiply the top and the bottom of this second fraction by x plus 1. Again, when you have the same numerator and denominator, 6 over 6 is 1. X plus 1 over x plus 1 is another way to write the number 1. Whenever the numerator and the denominator match, as long as it's not 0 over 0, then we say we're multiplying it by a form of the number 1. And now let's rewrite the limit doing so. So we see this first fraction gets a 6 in the numerator. We're going to leave the denominator in factored form. And now we're subtracting. And this second numerator is going to become x plus 1 over and 6 times x minus 5 times x plus 1. And we say, great, now we have matching denominators. When you have matching denominators, what should you do? You should combine the numerators. And the part that students sometimes botch up is this minus. This minus has to distribute over the numerator. So this limit, as x approaches 5, becomes 6 minus x minus 1. And because we're combining it, we can put it all over the same denominator. And now we want to simplify the numerator. So now our limit, as x approaches 5, is 6 minus x minus 1, which gives us 5 minus x, over 6 times x minus 5 times x plus 1. And we say, well, we still can't quite cancel these two, but what if you factor a negative 1 out from the numerator? Then we get the limit, as x approaches 5, of negative 1 times, and now the x will become positive, and the 5 will become negative. And now we see we've got the x minus 5s to cancel. And we say, eureka, because that is what was causing our zeros to show up in our denominators. So if those cancel, now let's plug the 5 in, and we get a negative 1 over 6 times, when we plug 5 into here, that gives us another 6. So the limit is negative 1 over 36. So the first one was identifying conjugates and seeing that after we multiplied it out, it would cancel our denominator factor. The second one, we were adding two fractions, and we said, let's find out the factors of the denominator, get a common denominator and combine, and it just so happened that it canceled out the factor that was causing our zero in the denominator.